help.
Okay, so what'd you get for your mean?
45,360.
Okay, I got 47,540, but it's different numbers, so that makes sense. So yours was 45?
Yes,
right?
45,360.
Okay, so I said for the C, does your sample mean appear to be unusual? Explain why you think it is or is not unusual. I think for both of ours, the sample isn't unusual because it lies within, like, it's pretty close to the mean, the overall mean.
What was yours again?
Mine was 47,540.
What's the range for it to be usual?
I think when it's outside or near outside of the curve, or when it's like really on the edge.
Okay.
But both of ours are like towards the middle.
Correct. Seven A obtain.
Okay, so D is compare your mean from question 7A to the mean obtained by at least 3 other individuals. So we only have 2, you and me. What do you notice in practice? You only get to see the mean from the samples you draw. You do not get to observe any other mean. So
Can we do it again and see what kind of answers we come up with?
Sure.
Okay. Since we don't have like 4 people.
Yeah.
You know, I think I imagine looking at these at all of the did you get it?
Almost done. I got 46,700.
I got 53,540.
53,540.
Yes.
Okay. Wow, yours is an outlier. 53, you said?
Now let me double check those numbers. No, I'm sorry. It's 42,760.
Okay.
Okay.
That's more regular.
You know what I was going to say? What I noticed is that I think regardless of any of the numbers that we put in, they're all going to be pretty close to the mean.
Yeah, that's what I was thinking too. So that's the answer for D.
I mean, yeah, all the numbers are in the in the same range for the most part.
Okay. So 8.
Criteria. Are we going to need to figure out the percentile for this?
I don't think so. We have to find out the shape of the distribution.
One second. Are you using SPSS right now?
No, I think you're supposed to be able to do it without that.
I'm sorry, I have a church call. Can I put you on hold really quick?
Yeah.
Okay, sorry. Hello? Hi. Okay, I'm sorry.
That's okay. So I looked on the answer key and it says, so the shape of the distribution of the samples is normal distribution. And then the next question is, how do you know that, basically? It says the parent population is normally distributed. Because it says the scores of the GMAT are normally distributed. So
I got you.
it makes sense that it's normal distribution.
Okay. Now we need to, let's see. So what's the mean of the sampling distribution?
So it says standard deviation is the standard deviation divided by the square root of the sample size. So 113 divided by square root of 10. Square root or, yeah, right?
I thought it was
Not the square root, the
it'd be like the
other thing.
it'd be the 113 over 10, right?
Well, it's 113 over 10. I'll show you. Whatever. I don't remember what this thing is called.
I just did this repeatedly this morning.
So you see it?
The mean of the sampling distribution of sample mean score for all such samples. I gotta go back and look at the formula. I don't remember how I did it.
Well, this is the formula, though.
What is it?
Do you not see my screen?
No.
The formula on D? You don't? It says I'm sharing my screen.
Okay, I see it.
Sorry, I skipped one. That's probably what's messing you up. Do you got it?
Yeah, I see it. I'm starting a little lost.
What is being distinguished? It seems like it repeats, like words are really similar.
Right.
Like standard deviation of the sampling distribution of the sample mean.
Is that everything? Are we ready to try the group quiz?
Well, do we understand what we just did?
A little bit. I could really use a little bit more practice, but we got to turn that in today, don't we?
Yeah.
Okay.
So just go ahead and do it, even though we don't really know.
Sometimes it clicks as you do it. Do you want to use a little bit more study time before we try this?
Well, I have something at 7, so I don't really have time to do more study time. So let's just do it.
Okay. Sorry if I'm not as helpful as I was last week.
Okay, so 3, when using the when taking sample of n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed? I think it was also right skewed, right?
It has to be.
When taking samples of n 100, what was the shape of the distribution of means histogram when the parent population was right skewed? Isn't it still right skewed? It's just a larger sample from the graph above it. Sample of the data.
Yeah.
Okay. So 5, when using the sample distribution applet when n5.
It'd be normal, right?
Yeah, it'd be normal. And then normal. Seems too easy. When would the distribution of means be normally distributed? Data drawn from the question information. Sample size is small. Well, it's definitely data drawn from a population that is normally distributed and sample size is large.
Correct.
Do you think it's small sample size as well? That's what we said on the last one. Well, it seemed to be like in the middle.
Let me just see if I remember it correctly. Distribution of means really is about accuracy with a large sample, correct?
I believe so.
So would it be large only, or would it be?
Yeah, that's the question. Large only or both? It's definitely not the right skewed one.
But I mean, if it's small, wouldn't it? Well, not necessarily. Wouldn't necessarily come out to the same average because you'd have to do it a lot to get a accurate number. Remember the coin flip example?
Yeah. Yeah. So you think? Well, it's so vague. Size is small. Like that could be like of a sample of like the data is like 1,000 and the small sample is 100. You know. So, I don't know. What do you think?
You know, well, I guess it's both.
Okay. I hope that's right. I don't know. Because, yeah, I don't know. Maybe we'll come back to it when we're done with the rest of them.
Okay.
Okay. So 8. Which of the following gives the best explanation of the central limit theorem? I think it's if the sample size is large, the sample mean will be close to the population mean. So the third one down.
Yeah, the same thing.
Okay. So 9. Let x be a random variable with population mean 10 and a population standard deviation of 6. Suppose a sample size of 36 is drawn from this population. What is the mean of the distribution of samples mean? So that's the 6 divided by the square root of 36.
Yeah.
So isn't that 6 divided by 6? Right? Yeah. So it's 1, right?
1 second. Yeah, I have 1.
What is the standard deviation of the what? Oh, wait. No, what is the mean of the distribution of samples? Isn't that's just 10. So 9 is 10, and then 10 is 1, right?
Oh,
Because
it's not asking us what the mean of the population is. It's asking us the mean of the distribution.
Yeah, but remember in the preparation assignment, it said that it was the same thing.
Gotcha. Okay. Deviation of the.
Okay. Right. What is the mean? Yeah. And then would 10 be 1?
I don't think so.
What do you think 10 is then?
Give me 1 second. Let me check my notes. We're allowed to use our notes, aren't we?
I don't know.
I mean, just the terminology is really killing me.
Yeah.
All right. Which number are we on?
10.
Standard deviation. Okay. So what's the mean of our sample again?
The mean is 10.
Minus 10. I don't know. Standard deviation sample mean is the standard. It's the standard deviation divided by.
Sample size, right?
Yeah.
So that's 1.
Or the population. Oh wait. Yeah, that's it. I think.
That's what I think too.
For 11, I have that it would be left skewed.
What? Say that again.
You have left skewed for 11?
Why?
I graphed it on the left skew. Was I wrong?
You did what?
When I graphed it out earlier, come on, let me take a look. Sample sizes. Oh wait, I'm sorry, I misread it. I'm sorry, I'm totally lost.
Yeah, so for this one, I guess I'm just guessing normal because, yeah, I don't know why. I don't know the answer to that one.
I mean, we have to create a graph to see it.
I don't think so. Because look at 12. What theorem would justify your response to question 11? So, like, if we knew the theorem, we would know the answer.
Gotcha. The size is large.
And I remember central limit theorem and law of large numbers was very similar, but there was a difference. I think I don't remember which is which, or I don't remember. I remember they said central limit theorem is like the most important one in this class.
So if I'm right, central theorem is like where it has to be normal based on the size. So I guess we explain it like just going back to the coin flip thing. That was a central limit theorem example, wasn't it?
I don't know.
Okay. So like have a large population and the graph should be normal, but it isn't if you only do a small sample of it. So you have to do lots of it so that it's...
Yeah. So then what's the law of large numbers?
Those two.
Yeah, that's what I'm thinking. I'm like, I don't know which one is which. Like if what's the coin toss law of large numbers or the central limit theorem?
I don't remember.
Yeah, me either. What was the other example?
I need more than 2 days on this.
Yeah. Well, I think 11 is normal, but because like I feel like that's for both of them.
Right.
But I don't know which law it is. Like it makes sense, law of large numbers, but I remember the central limit theorem being really similar to it. But like since it's if the sample size is large, like larger than 30, it makes sense, law of large numbers, right?
Right.
So that's what I'm thinking, but I don't know because I remember the other one's really close to it too. So and I think it has something to do with more numbers. But yeah, I don't know.
I don't have an answer. I gotta figure this out a little bit better. We're gonna go with that?
Yeah. Okay, we're ready to submit. And you got all of yours marked, right?
Yes.
Okay, here goes everything.
Eh.
Dang it.
That's
Ah.
not moral. Oh, okay.
Dang it. Well, dang it. Oh.
Well, maybe we'll have better luck with the probability.
What?
Maybe we'll have better luck with the probability.
I hate probability.
I like probability. I'm a lot more comfortable with that.
That's good. And Clayton, so today I got a call and I start my job tomorrow.
Okay.
So I don't know when we're going to meet.
I have a laptop now, so if you need to meet during the day sometime, I can do that.
You can?
I can.
Okay.
Laptop.
Okay, so I start work at 2 on Thursday. That won't be the normal. Normally I'll start at 3, but
Okay.
and then I get done with class at 9:30. No. Yeah, 9:30. So we could do like 10 or 11 on
That's
Thursday.
fine. Whatever works.
Okay, let's just do how about 10:30? So that'll give me some time to refresh my memory on the math.
Okay, that'll be fine.
Okay. Do you want to, okay, so since you have a laptop, do you want to just make a staple time forever?
What time is it again?
10:30 on Thursdays?
Evening, right?
No. Well, yeah. Well, like in the middle of the day. So it'd be like
I can try. It kind of depends on what's going on in the office.
okay.
Like if I have clients coming in, I can't make it at 10:30, but
So that would be 11:30 for you, you know, right?
yeah. I mean, either way, it's still in the middle of the workday, so it's kind of dependent on what's going on in my office.
Okay, so
For myself, it's not an issue.
okay. So we'll just do it from meeting to meeting then.
Right.
Okay. I think, do we have to set up an appointment with the class TA?
I thought they said. I thought they just.
Do they just drop in?
Yeah, I thought they scheduled it.
I'm just asking. I don't know.
No, I can email her and find out though.
Okay.
Okay.
Okay. So see you Thursday at 11:30 your time.
Yes.
Okay. Sounds good. Okay. Have a good night.
You too. Take care.
Okay. Bye.
Bye.